Alright, this section is the third section, I think, of our unit. This is on interval and inequality notation. Now, you should be familiar with inequality notation, and it's a way of saying what numbers belong in general terms to a solution set. Okay, it's just describing a group of numbers, and this is the way we can do it. Let's use the variable x here to describe all the numbers that are shown in the red line on the number line here. If you notice, it starts at 1 and then it points to the right, which means it goes to bigger and bigger numbers. And every single number from 1, including 1, notice the dot at 1, and all the numbers on the red line, the fractions included, and the whole numbers 2 and 3, and all the decimals, and all the irrationals, everything bigger than 1 is covered by that red line. And so if we want to show that in inequality notation, we just say the numbers x are all bigger than or equal to 1. Okay, and that's what we should be familiar with. Now, the new stuff is how we do this in what's called interval notation. In interval notation, we use parentheses and we use square brackets. The square brackets mean to include the number, and the parentheses mean, like an open circle, just mean right up to that number. And so let me show you the use here of a square bracket. For the numbers in this set covered by the red line, I would say, hey, this interval starts at 1, that's the starting point, and then you put a comma and you say how far it goes to. In this case, it goes all the way out here to forever, to infinity. And so we say that the interval the red line covers is from 1 all the way to infinity. It includes the 1, so we put a square bracket to the left of it, saying the 1 is included in this set. And for infinity, we always put paren, because there is no endpoint to include in infinity. It goes on forever. And so this would be the interval notation of what x is, and this would be the inequality notation. Let's look at another one. Here we have a closed interval. We call it closed because the -3 is included and the 2 is included, and everything in the middle between -3 and 2 are in the solution set. So to show this with inequalities, we'd say x is less than or equal to the 2. Okay, so we're smaller than 2. We're numbers down in here, but we don't go past -3 because we are bigger than or equal to -3. So there is inequality notation. Interval notation is much simpler to write. We just say, hey, we start at -3 and we end at 2, and those endpoints are included. And that's interval notation. Next one, we got an open or a half open interval. The 3 is not included, but the 4 is included. So again, in inequality notation, we'd say x is, he's less than or equal to 4, but we're just greater than -3. Notice we don't have greater than or equal to -3 because the 3 is not included. That's what the open circle means. So there's our answer in inequality notation. In interval notation, we'd say, hey, we run from -3 all the way up to 4. The 4 is included, but the -3 is not. And so there's our interval notation. And lastly, I may do one more after this. This one's a little bit more complicated. We have two different regions here. We got from -4 to -1. That's one region, so let's cover that guy first. In inequality notation, we'd say x is less than -1, not less than or equal to because the open circle, but greater than or equal to -4. And then or, because you can't be in both sets at the same time, or x is greater than or equal to 2. And so that inequality, or that combined or joint inequality, describes the solutions there. In interval notation, it gets a little bit trickier. We do the same thing for the interval from -4 to 1, just like you'd expect. We go like this. We say the -4 is included, but the -1 is not. On the right hand side, we say we start at 2 and it goes to the right forever. It goes to positive infinity. The 2's included, but infinity is always an open end. And to say that it's the combination of these two, we use a kind of a U-looking shape. This stands for the union of these two steps, or these two sets. And the union just means you can be either in one or the other, or you could possibly be in both, although no number is in both in this case. So that would be our union set, or our interval notation rather, for the set of numbers that are underneath these red lines drawn on the graph. Let's do one more, because I didn't show you one that went to negative infinity. So I'm going to draw a line here. Let's have this one go from positive 1 to negative infinity. Okay. In inequality notation, I'd say x is, let's make this filled in right there, x is less than or equal to 1. And in interval notation, it goes to negative infinity, so that's kind of my low number. So I put negative infinity is where it heads to, and it runs all the way up to positive 1. The positive 1's included, and infinity again, even though it's negative infinity, gets a paren. And that's how you do interval notation and inequality notation. Your homework, as usual, is on the website. So go there to get it if you did not get it in school, and I will try and get the answers posted this evening.